Given an insurer has to pay compensation benefit to a worker, the IP, who has recently suffered a workplace injury, the insurer uses the following model to value this benefit. So the IP is currently 45 years old and is in state 0. The insurer will pay a renewable or reviewable continuous annuity of $80,000 per year until the IP recovers or dies. So this means that it will not pay $80,000 if the person has recovered or is dead. So the only two states where the person will receive $80,000 is either in state 0 or state 2. So we want to calculate the expected present value of this annuity. So keep in mind this is continuous. So this will pay $80,000 if it's continuously in state 0, or if it transitions to state 2. All right, so because it's continuous, we can actually calculate using an integral. So we'll go from 0 to infinity, Vt times Tp 45 dt, and this is staying at state 0. Force of interest is 5%. Okay, and this will be e to negative. Now we have to add up all of these 3. So that'll be 0.23 t dt. So that'd be e to negative 0.28 t dt, which is same thing as 1 over 28, 0.28 I mean, which is 3.5714. So that's the first annuity. Now we want to look at the second annuity. So this one, we're going to need the probability of transitioning from state 0 to state 2. Okay, so let's do that on the side here. So the way we're doing this is we're going to stay in state 0 for some time. So that was 0.28 t. And then from state 0, we're going to transition to state 2, which is 0.12. And then we're going to stay at state 2. So that is after, let's say, I guess we should say a period s. We don't want to use the same variable. So there's a t here, so you want to use a different one. So we're going to stay in state 0 for s years. So that leaves us t minus s years to stay in state 2. So let's see. This will just be negative 0.05. Okay. Let me kind of draw this. So let's say from 0 to 2, we'll stay here, stay in 0, and then at time s, that's when we transition to state 2, and then we stay in state 2. So that's what the formula above here is showing. So when we find this, we get 12 over 18 times e to negative 0.05 t minus e to negative 0.23 t. So when we go back to the integral for the annuity, we're going from 0 to infinity, Vt times Tp h45, going from 0 to 2. Force of interest is 5%. And then the probability is 12 over 18 times the quantity e to negative 0.05 t minus e to negative 0.23 t. So I can write this, I can pull out the 12 over 18, distribute the e to negative 0.05 t. So I get e to negative 0.1 t minus e to negative 0.28 t dt. Integrate, I end up getting 12 over 18 times the quantity 1 over 0.1 minus 1 over 0.28, which is 4.2857. So we have both annuities solved. So we're going to add these and then multiply by 80,000. Get a final answer of 628,571.43.